Hello everybody and welcome to the Homework Helper for section 2.5. This is the 2017 edition. Alright, so let's go ahead and begin. The first topic on our homework is going to be on simplifying radicals. And it talks about how a very common radical expression is the square root. And so what we're going to be doing is we're going to be trying to simplify these square roots. For example, square root of 2 is a number that will multiply by itself to equal 2, and in that manner, square root of 16 is a number that will multiply by itself to equal 16. And in this case, we know it's 4 because 4 times 4 is 16. And then it gives us some examples of how this works. Okay, we know that 2 cubed is 2 times 2 times 2 is 8. So we know that that's the cube root of 8 is going to be 2. It also gives us an example for here. We have root 20. Root 20 is 4 times 5, right? Because 4 times 5 is 20. And then 4 we can break down to 2 times 2 times 5. This right here is a square, so we can pull that out. So we have 2 outside of the radical. Likewise, when we have the fifth root of something, if we have something to the fifth, it simply is that thing. So I'm going to do a handful of these in hopes that you guys can help understand what's going on here. So I'm going to go ahead and zoom in just a little bit. So the way that they do it here is they put everything under the radical, and that totally works. So like 40 would be the same as, well, what two numbers multiply to be 40? Well, I know that 4 and 10 multiply. And then do two numbers multiply to be 4? Yes, I know that that's 2 and 2. Do two numbers multiply to 10? Well, yeah, that's also 2 and 10, or 2 and 5, pardon me. So I know that 2 times 2 times 2 times 5 is 40. Now what I need to do is I need to look to see if I have any squares. Do I have any numbers that multiply by themselves? And sure enough, I do. I have a 2 times 2 here. That's a square. And then I just have a 2 and a 5. Those aren't the same number, so they're not a square. So since this is a square, this would be the same as the square root of 2 squared times 2 times 5. And since I'm taking the square root of a square, that's the same as just pulling that out of the radical. So square root of 2 squared would be 2 radical, and then whatever's left over, because I've taken care of this. 2 times 5. Can't simplify that further, so let's just do 2 times the square root of 10, and that will be my answer. That is one way of doing it. The way I like to do it is when I look, I'll do this one for this one here. We have the square root of 50, right? So when I look at square root of 50, instead of factoring out long ways underneath the radical, I like to do a little factor tree. So this is 5, this is 10, this is 5 and 2, okay? So I know that my factors are 5, 5, and 2. And sure enough, we do know that 5 times 5 is 25 times 2 is 50. So we know that those are the same thing. So the square root of all of this is the same as the square root of all of this. But when I look for this, I see that I'm looking for a square root. No number there means it's a square root. So now I look for groups of 2, and I see I have 1, 2, 5s. That tells me that these 5s can go out of the radical. So I end up with 5, and then what do I have left over? 2, radical 2. So 5 square root of 2 will be my answer. Okay, I'll do that again for this one here. So we have the cube root of 16. So let's go ahead and do the factors of 16. Okay, I know that's going to be 8 and 2, and then this is going to be 4 and 2, and this is going to be 2 and 2. But now I'm looking for the cube root. So I'm looking for 3s. I need to find 3 of a kind. And so here's 1, 2, 3 2s. Since I have those 3 2s, they pull out. So I have 2 radical cube root radical, what do I have left over? Just a 2. So 2 cube root of 2 is going to be my simplification because I had 3 out. Now when we got to this step, this would be the same as the cube root of 2 times 2 times 2 times 2, right? 1, 2, 3, 4 2s. And then I see that I have a cube here, so that pulls out as well. Both ways work. Let me write that too so it's a little more clear. All right. So that's how those work. Let's go to the next section. Okay. The next one, it's asking us, whoops, let me scoot this down. Set, topic, find arithmetic and geometric means and make meaning of rational exponents. You may have found arithmetic and geometric means in your prior work. Finding arithmetic and geometric means requires finding the value of a sequence between given values for non-consecutive terms. In each of the sequences below, determine the means and show how you found them. So it starts by saying, okay, let's find the arithmetic means. And when we're finding arithmetic means, we have two real ways of doing it. We can, one, use a formula, use the slope formula, or we can, two, create an equation. And so, let's get that on screen there. Boom. Use the slope formula or create an equation. So when I'm looking at number 10 here, we can do both of those. We can either use the slope formula or we can create an equation. Or if you can just look at it and see what's going on. When we're doing the slope formula, we have to remember what our slope formula is. Okay? We have to remember that our slope formula is our delta y over our delta x, which is our y2 minus y1 over x2 minus x1. And this will tell us our constant rate of change. So my x would be 3 minus 1 over my y's. Whoops, I did this backwards. See, this is why we do this. So this would be 11 minus 5 over 3 minus 1. 11 minus 5 is 6 over 2, which is 3, so 5 plus 3 is 8, plus 3 is 11. Boom, got it. Now we could also do this by creating an equation, right? Because I know that this is 5 plus my constant difference, and I know that this is 5 plus 2 constant differences, right? Plus a constant difference, plus a constant difference. So once I have this, if I know that 5 plus 2 constant differences equals 11, I know that 2 constant differences equals 6, so I know that the constant difference is 3. So it's worked exactly the same way. All right. Next, geometric means. Again, we've got a couple different ways of being able to get our geometric means. Okay. So our ways for finding our geometric means are, one, use the means formula, the geo-means formula. And remember, that was x2 minus x1 root of y2 divided by y1. Or we can also build an equation. Okay. So when I look at number 13 here, that's exactly what I can do. So I'm going to start actually by building an equation. I'm going to try it that way first, because that way is more fun. So I know that this is some ratio. I know that this is some ratio. So I know that 3 times a ratio squared is going to equal 12. So I know that my ratio squared equals 4. So I know that if I take the square root of 4, it's going to equal my ratio. Now, because this is an even root, this could be plus or minus 2, right? So I could multiply by 2 here. That would get me 6. I multiply by 2, it could get me 12. Or if I multiplied by a negative 2, this would give me negative 6. Multiply by another negative 2, I would get a positive 12. So it's plus or minus 6. Let's go ahead and look at one that's a little bit more complicated. Okay, let's go ahead and look at these half ratios. Okay, it says fill in the whoops, I'm too far up. It says fill in the values and find the factor used to move between whole number values f of w as well as the factor f of c used to move between each column of the table. Okay, so we need to figure out how much each whole step is, that's the f of w, and how much each half step is. Okay, so to go from 4 to 16, okay, we know this is geometric. To go from 4 to 16, I know that I've multiplied by 4. Okay, now each half step, well, it's fc times fc. So this fc squared has to equal my fw. But I know my fw is 4. So fc squared equals 4. So if I square root both sides, I know that fc equals plus or minus 2. Okay, so this is plus or minus 2. Because if I multiply by by plus or minus 2, right? So this becomes 8 plus or minus times plus or minus 2 would be 16 times plus or minus 2 would be 32 times plus or minus 2 would be just a 64 because we know 16 times 4 is 64. Okay, I'm going to do it one more of these because I feel like this is one of the more challenging ones. Okay, let's do this one. Okay, same deal, right? So I know that f of w is going all the way over here. So 4 times what is 8? I know that's going to be 2. Okay, that's going to be 2. So that means this will be 16. But now, what times what is going to equal 2, right? F of c would get me here. F of c would get me here. So f of c squared equals 2. So I have to take the square root of both sides. So I get f of c equals plus or minus the square root of 2. So if this is plus or minus the square root of 2, this is going to be 4 times square root of 2, positive or negative, times another square root of 2 would give me 8. This is going to be 8 times the square root of 2, positive or negative, and then times the plus or minus square root of 2 would give me a positive 16. So that's how we build that. Some of you may be wondering, Victor, why is it plus or minus? And I just want to reiterate, it works either way is the issue. We can't know for sure because 4 times a negative number times another negative number would get us back to positive, right? Because if this is negative, negative, positive times a negative is negative, times a negative is positive. But if it's positive, positive, of course it's going to be positive, positive. So we don't know if it's plus or minus. All right, finally, evaluating functions. It says either find or use the unit rate for each of the questions below. So if it gives us the x, we solve for our f of x. If it gives us the f of x, we solve for our x. So f of negative 3, that means let's plug in negative 3 into our equation. 2 times a negative 3 is negative 6. Negative 6 minus 7 is negative 13. F of x equals 21, so we need to find our x, so 21 equals 2x minus 7. If we add 7 to both sides, we get 27 equals 2x. If we divide by 2 on both sides, we get x equals 14. We have found our x. And then finally, f of 1/2, so we plug 1/2 into our equation. 1/2 minus 7. A half of 2 is 1, minus 7 is negative 6. Okay? So that's all it's asking us to do. Remember, if it's put where the x is, we plug it in for x. If it tells us f of x equals something, that means we don't know what x is, and we need to find what the x is. All right, guys, that should do it. Good luck on your homework, and we'll see you next time.